Hello and welcome. In this video I'm going to show you how to create a simple match 3 game in Unity Engine. The end result will be something similar to this. So as you can see, you can match 3 or more items or tiles together. And we have different scores based on the item inside of each tile. And we can match more than 3 or more tiles in different arrangements. So as you can see here, this is a row. And this is like an L shape, and here we have another L shape. So it's pretty simple and fun concept. So we will get started right now. First, we'll need to download an asset from from the asset store called Tween. It's a very powerful tweening and animation asset for Unity. It's free and it's very useful. So we're going to download this. Let's go into Unity and go ahead, package manager, select my assets, search for Tween and select the free version. If you have the pro version, it's basically the same except for like the visual editors, but we won't be needing this, so we'll just use the free version. Let's click on import. So once it's imported, you will see a panel that opens, like a window that opens this panel, and we need to set up the assets, so we do this by clicking on setup Tween. Now, okay, disable all these 3 modules and click on apply. It's going to start compiling some stuff here, and yep, it's done. Now before closing the utility panel, we go to the preferences and we're going to change some settings here. We're going to set recycle tweens to true. I'm going to disable autoplay by setting autoplay from all to none. We're going to change the ease to an out sign. I just prefer this, you can choose whatever you like. And we're going to keep autokill on. And we're going to change the settings location from assets resources. We're going to change it to Tween resources. So once you've done this, let's close this window. So you might notice I already have some assets here, which is just a simple sound effect for when you collect the items or when you match the tiles. I will link this in the description. And we have some sprites, some cute animal sprites made by Kenny. You might have heard of him. He is a very generous asset creator. And this asset's free on his website. It's called Animal Pack. I'm going to link it as well. So when you go and download it, consider becoming a patron for him or donating some money. So that's pretty much it for all the assets we'll be using in this tutorial. Let's get started by creating our scripts folder. Okay, and we're going to create a script called row. Create another one called board. Okay. Create another one called tile. And finally, for now, we'll create a fourth script called item. And once this is created, we'll just let the editor compile. Okay, and now let's set up our editor. So I'm building for WebGL, which shouldn't really matter. You can build this on any platform. So my camera is set up as follows. You can pause the video and check the settings out. So to create a simple match 3 board, we're going to need a UI canvas. You can just call it canvas and rename the event system to be in the snake case. We're going to go inside the canvas, change the UI scale mode to scale with screen size. You might want to keep it a constant, whatever. I'm just going to scale it with to the reference resolution of 1280 by 720, and move the match from the width all the way to the height, so it matches depending on the width. You might want to change this as well, so it really depends on the platform or the device or like the operating system you're targeting. Sorry, not the operating system, just the device, okay, or the screen resolution. In the canvas, we're going to create an empty object and call it the board container. I'm going to set it to fill the entire screen. Okay, it's going to be an empty object just to hold our actual board element. Let's right click here and create a UI image and call it board. I'm going to set it to fill the parent, but this is going to change in a second. I'm going to set the source image to a background. Okay, I'm going to go back to the board container and add some spacing from the left, the top, the right, and the bottom. So as you can see, it's now 10 units from each, 10 pixels from each side. Let's go back to the board object and let's go all the way down and click on Add Component. Let's search for aspect ratio or aspect, and it'll show you this component called aspect ratio feather. Let's select it, and we're going to go to the aspect mode and make it fit in parent. Okay. So just before we do this, let's change this real quick. So remove the component. Let's go up here, set it to center. Okay, set the width maybe like 512. Add the component again and say fit in parent. So this will basically make it. I could have made it from this aspect ratio field here. This is just an oversight. Sorry. So as you can see, it will always be a square, regardless of the resolution. As you can see, even with strange ones like this. We're just going to stick with 16:9 aspect ratio. So let's go and change the board background, make it a little bit transparent. And let's start by creating our rows. So a row is going to basically hold some tiles, but to create this we need like a grid layout. Unfortunately, the grid layout in Unity doesn't allow like flexible spacing, but this can easily be worked around by creating, like by going inside this on this board object, adding a vertical layout group. Okay, we're going to set the padding from the left, right, top and bottom to 10. We're going to set the spacing to 10 as well. We're going to change child alignment to upper center. We're going to control child size, width, height. Okay. We're going to use the child scale. Yes. Once you've done this, we're going to right click here and create an empty object and call it row. So currently this row doesn't have really anything, so we're going to add an horizontal layout component to it. We're not going to add any padding, just going to make it change the spacing and make it 10. I'm going to change the child alignment to middle left. I'm going to, as was like previous, change the control child size and make the width and height true. Use the child scale true. And go inside the row object and just drag it, and select the row object and drag it and drop it on your assets to create a prefab. Let's create a prefabs folder real quick. Let's drag it and drop it here. So we now have a row prefab. Inside the row, we're just going to create a new tile, a new game object and call it tile. So our tile object is going to be very simple. We're going to use an image, add an image component to it. Choose the source image to be the background image. Keep it sliced true. And inside the tile, we're going to add another image and call it icon. Okay. I'm going to set it to fill, but with some spacing as well. Okay. I'm going to choose the sprite to be the UI sprite, and we're going to change the image type to simple. This will change later. It might look ugly right now, but it will be fixed later on. Let's toggle use sprite mesh and preserve aspect, so your tiles, like the tile icons, look better later on. And be sure to disable the raycast target. Go back to your tile game object and add a component called button. So as you can see, this will make our tile clickable. Let's change the fade duration to something like this. And let's go ahead and create a prefab out of this tile object. And depending on your game, you might have 5 tiles per row, 10 tiles per row, whatever. So I'm just going to have 5 tiles per row. Let's apply the changes. Let's go select the row, add 5. Oh, wait, just make this a little bit easier on ourselves. Tile 1, 2, 3, 4, 5. So as you can see, we can change the number of tiles to whatever we see fit, but I'm going just to use 5 tiles per row. Now go back into the board and duplicate the row 5 times as well. And as you can see, we have a grid layout that is flexible. If you were to go and change, for example, the aspect ratio here, you might see that the cells change size as well, and they retain their position in a grid-like or table-like form. I'm just going to keep it 1, so it's a square. Once you have done this, let's go and begin scripting. The first thing that we need to do is go to our row script. So first we'll be using Unity engine. We need to have a public sealed class row that inherits from mono behavior. It's going to have a public field that's called of type tile array. So let's go tile and add the double square brackets to indicate that it's tile and call it tiles. This is pretty much it for the row class. It's very simple, but it's very useful, and our game heavily depends on it. So let's close this row class, go back inside of Unity, select our row object and go into the prefab, drag and drop our row script or row component on here, and drag and drop each tile here. But beforehand, let's go to the tile object, go to the prefab itself, add it add the tile script, go back to the row and start adding the tiles to the tiles array in the row script. So now we have 5 tiles, and if we go back to the scene, we can see that all the rows have the same thing applied to them. After we do this, let's go inside the tile script, remove all the code inside of it, make it a sealed class because we're not going to extend it in any way. Let's remove the unused directives, and let's add some fields right here. So first we'll need a field called public int x, public int y, which are the coordinates of the tile and the board space. Let's go and add a public field of type item and call it item. Let's go ahead and add a field of type public image from the Unity engine.ui namespace and call it icon. I'm going to have another field of type button, just call it button as well. So this is pretty much it, the basic tile script that we're going to have right now. So let's go and do the item script. So let's go into Unity, double click on item, remove all the code inside, and let's inherit from scriptable object, seal our classes, and let's add the attribute called create asset menu. Set the menu name to equal match 3 item. So this will make will add a menu item when you right click, or add a context action when you right click in the project window that allows us to create new item instances. This will be shown right away, but let's finish the class first. Let's go and add the public sprite icon. Let's call it item sprite anyways, and let's go and before this field add a public int value. So this value field over here is going to be how much this item gives us when we gives us per match. Like for example, if we match 3 tiles with this item, if this value is 3 for instance, then this match is going to give us 9 points. So that's pretty much it for the item class. Let's close it and let's close the tile class for now. Let's go into Unity, and as you can see, when we right click in the assets folder, create, you'll see a new entry called match 3, and there is our item item creation context action. If we select it, you'll see it creates a new item. You can change the value and assign spreads to it. So let's not do this right now. Let's delete this. And let's go inside our board script. This is the main thing. This is the most important class in all of our project. So, as we did before, let's seal this class. Let's keep these namespaces. We might need them right now. Let's add a public static board instance get private set. This is a static property called instance that can only be set from excuse me, inside this class. This is basically like a singleton that we're going to use throughout the tutorial, so it's useful to have instead of using like find game object or using tags and messy stuff like this. So let's go and add a private void awake, which is a built-in Unity as it's called magic method, and let's assign the instance to this, and let's add some fields to our board script. First, we need to add a public row array, call it rows. We're going to have a public two-dimensional tile array, and we're going to call it tiles. My naming convention is that the fields that are not serialized and are public are going to be uppercase, while the ones that are serialized are going to be lowercase. You can follow whatever convention you prefer. I just use this to make things a little bit more clear. And then since this tiles field isn't going to be used by Unity, let's just turn it into a property that can only be set from inside this board class. So let's go ahead and add some other fields, like a public int width, which is going to be the width of the board. We're going to go ahead and say tiles.getLength 0. So what does tiles.getLength mean? Normal arrays have a single length property, which is the number of items inside this array, but multi-dimension arrays might have different lengths for each dimension. So let's say, for example, you have a table. It might have a different number of columns and different number of rows, so the length isn't the same for these two different dimensions. So this is what getLength and dimension, like getLength takes in an integer as a dimension does. It returns the length of that specific dimension. So we have a public int width, and we have a public int height, tiles get length, and choose the first or like the second dimension as the dimension to return its length. After this, we're just going to go ahead and start initializing our table, or like tiles and the board, stuff like this. So private void start. But you might say, how do we... Oh, excuse me. Notifications. Shut up. Okay. How do we know the width and the height of the tiles array before we even like initialize it or create it? Well, remember we have in our row class this tiles array. So we can return we can like get the maximum number of rows, of tiles in a single row, and use this as the width of our entire board. This is a simple implementation. You might have a game with variable row length or variable row size. It's going to be a very simple change, but we're going to stick with the maximum number of tiles in a row as a width. So, and this leads us to set tiles, to set the tile array to be something like this. So I'm going to create a new tile. The width is going to be rows.maximum, which is an extension method from the system.link namespace. I'm going to say row. I'm going to return tiles.length. And the height is going to be basically the number of rows that we have. So I'm going to go ahead rows.length. And that's pretty much it. We just need to assign the tiles to their respective cells or indices in the array. And to do this, let's go ahead and create a for var y equals 0, y is less than width, y is less than the height of our board, y plus plus. For var x equals 0, x is less than the width, x plus plus. And here we're going to set the tiles to be tiles at x and y equals basically rows y dot tiles x. So what this means is the tile at this x and y is going to be equal to the tile inside the row at the y index, and the tile's index is going to be x. So it's a pretty simple thing. Let's remove the braces. It's a simple, it's a pretty small 2D loop. So once we do this, we need to go ahead and start adding the icons and how to change the icon or item per tile. So let's remove these extra 2 lines. Let's go inside our tile class. Let's change the item field here to be private. Okay. Let's add an underscore. And let's go ahead here and add a public item property. It's going to return this item field here, and it's going to set if the item doesn't equals the incoming value. So if we already have the item assigned to this tile, don't do anything, don't waste time processing this function. Otherwise, let's set the item to the incoming value, and let's set the icon.sprite to item.sprite. So this basically checks if we, as I said before, have assigned this item already to this tile, and if not, it'll assign the item and change the icon automatically for us. Okay. So let's go into our board here. Let's go inside of the Unity editor, and wait until it compiles. Let's create a new script and call it item database. So item database. Okay. Wait until everything is compiled, and the item database is going to be a simple helper class. So let's remove all the code that comes into it. Remove the dependency on the main mono behavior. Let's make it a static class, and let's remove the collections namespaces. And here what you're going to have is something a little unusual. So first we're going to have a public static sprite array, and we're going to call it item array. We're going to call it items. We're going to be get a private set, so it can't be set from the outside this class. And we're going to have a private void, static void initialize. Let's use the expression body method. Say items equals resources dot load all items and the items folder. So what this call over here will do is, let's go first to the Unity editor, and let's go ahead and create a new folder, call it resources, and let's add a new item, a new folder, call it items, and let's say we have an item here called, let's see, giraffe. Let's assign the giraffe sprite to it. Let's give it a value of 5. Let's say we have multiple items here, inside this items folder. So what resources.loadAll does is it grabs all of the item assets inside of that folder and stores them into our items array. So it's a little bit more convenient and easy to access. But you might say, how are we going to call this initialize method? So the folks at Unity gave us this powerful attribute called runtime initialize onload, which basically calls a static method automatically for you at a specific moment of your application or game's initial lifetime. So as you can see here, we have a runtime initialize onload attribute, and it takes one of the 6 enum values here, sorry, 5 enum values here. Subsystem registration, after assembly is loaded, after scene load, before scene load, and before splash screen. These options are pretty self-explanatory, but we're going to go ahead and choose the before scene load. So it does load all of our assets before the scene is loaded. So once the scene is loaded, we can easily access them without like having to wait for the assets to load and stuff like this. So that's pretty much it for the item database class. Let's go inside our board, and again, for each tile, let's just gonna add the brackets since our loop is going to have multiple blocks inside of it. So to make it more clear, let's go. Tiles xy, we're gonna store this in a variable. So var tile equal rows y at tiles x. We're going to set the tiles at the current coordinates to the tile. We're going to set the tile dot item. So as you can see, what's exposed now is the property. Let's double click on this, and let's say equals to item database dot items, and we need a random item. You know, it might not be the best way to implement this like board initialization mechanic, because you might get initial matches or no matches at all, so it's kind of random. You might want to follow or do something else, like maybe check for each tile and see if you want to add the same item twice or not. You want to start with a specific layout. It's all up to you. In this tutorial, I'm just gonna do a random item picking. So how do we do this? So we index the items array using random dot range, and we take the first argument as 0 and the second one as item database dot items dot length. So say we have 5 items, it's just going to pick an index between 0 and 5, and then return this this number, okay, and this number will be used as an index and return the item at that specific index. Okay, so let's save our class. Let's go inside of Unity. Let's add some more items. So I'm going to create items for all of the animals that we have. We have the hippo, the monkey, the parrot, the penguin, the pig, and finally the snake. Let's drag and drop the snake sprite, and I'm gonna give the snake 3 points. You know what? 2 points only, because snakes are bad. Joking. I just kind of afraid of snakes. So as you can see, we have now 7 items, and they should be randomly chosen. Let's just go to our tile prefab first and confirm that we have assigned all the proper values. So this isn't the case, so let's go ahead and do this. Let's assign the icon, and let's assign the button component. And one important thing is the X and Y. We forgot to assign them when we are initializing our port. So let's go inside port.cs and assign the tile specific coordinates. Just remove this from here to the bottom. Say tile x equals x, tile.y equals y. Wait until the editor refreshes, go inside of Unity again, excuse me, and if we now run our game, it should have, each tile should have a different sprite. Let's go and see. And they don't now, for some reason. Let's check. Oh yeah, because we forgot to assign our rows to our board instance. So a mistake, sorry. We even forgot to add the board instance at all. So let's drag the board script and add it to our board game object. Let's drag the rows and make sure that everything is in order, because if you add some rows before others, it might corrupt everything and everything will be kind of wanky. So be sure to add everything in order. Let's run the game now, and everything should excuse me, have a random sprite, which is perfect. So this is the basic thing. Let's go ahead and now start adding like swapping and popping the items or collecting the items. I like calling it popping because, you know, items pop from the board and disappear and new items are generated. Let's go ahead and start doing this. Let's remove this. Unused namespaces. Let's go ahead here and add a new public void select, and it takes a tile as a parameter. So we have a simple method called select that takes in a tile as a parameter. But since our board game, you need to select two items to swap together, we're going to add a couple of private fields here. So private tile selected tile 1, private tile selected tile 2. Or a better way would be to go ahead here and have a list. So read only list of tile. I'm going to call it selection. I'm going to initialize it in place. I'm going to go all the way down here and I'm going to do a couple of checks. First, we're going to go ahead and say if selection.count is less than 2, we return. So any code after the statement over here, if we didn't select two tiles, will be ignored. And before this, we're going to go ahead and say selection.add tile. Oh, sorry, tile. And before we add the tile to the selection, we should actually check if this tile isn't already contained in the list. So if selection.contains tile, not. So we're going to say selection.add tile. So that's basically the first thing here, but we need to go down and after the selection.count less than 2, check. We're going to go ahead and say selection.clear. So after we have selected and done all of our like matching and popping operations, we're going to clear the selection. And to indicate that we did this, let's go ahead and say debug.log selected tiles at, let's go ahead and print the tile coordinates. Let's go selection 0.x and selection 0.y. Then we go ahead and have selection 1.x and selection 1.y. If we go to the editor now, we need to go to our tile script and in a start method, so we're going to have a private void start. Inside of it, we're going to add a callback or like a callback to our button. So button.onClick.addListener. So basically what this does is when I click on this button, it will add a listener. So when I click on the button, it will execute the code that I add between these two parentheses. So what the code will be is a simple lambda expression that does call board.instance. You see the singleton coming in use now. Let's select this. And what this does is basically tell the board to select this tile. Let's convert it to an expression body. And let's go inside of Unity again. Let's double check that we have assigned the button. It's already here. Let's go and attach the console to the top here, and let's run our game. So we have these two tiles over here, which is I think 0, 0 and 0, 1 or 1, 0. So let's check this, 0, 0 and 1, 0. So let's select them and see what will the console say. And as you can see, it correctly works. So let's see, I select this and this, this and this, and it works. So this is our selection. Now for the swapping part, which utilizes .tween, let's close, let's end the game mode, let's save our project, and let's go into writer. In the board, let's add a public void swap. So what swapping does is swap two tiles together. Let's say tile 1, tile 2. This function might be a little confusing, so be sure to focus very well when I'm writing it. I'm going to explain everything, of course. So first we need a reference to the first and second icon. So icon 1 equals tile1.icon. var icon 2 equals tile2.icon. We need a reference to each of the icons transforms. So let's go icon 1 transform equals icon 1.transform. And we need a reference to the second icon's transform equals icon 2.transform. And we need to change the swap from being a void to be an asynchronous task, which is inside system.threading.tasks namespace. So basically what tasks is, this is a very high level explanation. I recommend that you go ahead and check more in-depth tutorials on these subjects, but to sum it up, a task is like a mini thread. It executes something, or let's say it's a coroutine, like a Unity coroutine. It's something that runs in parallel and can be awaited, delayed, or run in a different thread, but in our case it's going to be something that is run in parallel that we can wait for. And you'll see how we're gonna utilize this. So we're gonna go ahead and now start the animation. How do we animate two sprites moving from one position to the other? So here we're going to have a var sequence, or no, not a sequence, sorry. Go ahead and have icon 1. Excuse me, very sorry, quite confused here. We're gonna have a var sequence equals .tween, which is the asset that we downloaded, .sequence. We're going to call sequence, await sequence .play .await for completion. So what this does is turn our awaits for our sequence to play and finish playing successfully. So this is going to be useful, so you can swap multiple tiles at the same time and break the game basically. So before we play it, let's go in the middle here and add some tweens to the sequence. So let's go sequence.join, which basically appends a tween that's run in parallel to other tweens as well. So here we're going to say icon 1 transform .to move to icon 2 transform .position. Let's introduce a constant up here that's going to hold the time it takes to finish the tweens. Tween duration. I'm going to use 0.25 f. Let's go here and say tween duration. Let's go ahead and say dot join icon to transform the do move icon 1 transform dot position, take tween duration. One interesting thing about DoTween that it allows us to add callbacks when the animations are done. So basically what happens right now is that the two icons just move from one position to the other, but nothing actually changes about the tile itself. So we'll go ahead here and await until the sequence is complete. Okay, we're going to change the parents and the excuse me, the parents and the icons of the tiles. Sorry, the parents of the icons and the icons of the tiles. To do this, let's go ahead here and say icon 1 transform, let's set parent to tile 2 transform. Since it moved to the second tile, it's going to be its parent, and the vice thing for the icon 2. So let's go icon 2 transform, let's set parent tile 1 transform. So this basically changes the parent of the first icon to be the second tile, and the second icon to be parents to be the first tile. Okay, but this is not everything. We're going to go ahead and set tile 1 dot icon equals icon 2, and tile 2 dot icon equals icon 1. Then after we set the icons, we're going to change the items. So we need to store the tile 1 item in a temporary variable. Tile 1 item equals tile 1 dot item. We're going to set tile 1 dot item to equal to tile 2 dot item. And then tile 2 dot item to be equal to the variable that holds the value of the tile 1, or the reference to the tile 1 item. If we didn't have this variable, if we change the tile 1 item to be the second tile, then attempt to set the second tile items to be the first tile's item, it will just reassign the same value to it, since now tile 1 item refers to tile 2 item. This is kind of confusing, but it's a real simple concept, and this code over here is explains it. Okay, so that's pretty much it for the swapping method. Let's go up here and change the select method to be asynchronous, and let's await the completion of our swapping task, which basically going to swap between selection 0 and selection 1. If we go inside of Unity now, okay, and we go to the scene view to confirm some stuff, let's open the first and second tiles and keep an eye out on the hierarchy now. Let's play the game or enter play mode. So let's swap the snake with the penguin, and as you can see, this icon now changed its parent, and the tile did get, let's go into debug mode, did get the correct item assigned to it. Let's swap this and this maybe. As you can see, it works perfectly. Okay. But right now, there is no matching and stuff like this, so let's go and implement this. Let's exit the play mode. Let's go inside of Rider here, and matching is going to require multiple things, and it might get a little complex, but hopefully I'll be able to explain it in a simple way. So let's go here and add a couple of methods, but not implement them yet. So private void can pop. Okay, I'm gonna go and throw new not implemented exception. So basically you haven't implemented it yet. That's going to return a boolean, and we're going to have another private void that's going to be called pop, and it's going to throw a new not implemented exception for now. Let's go into our tile.cs and add a method. Add a couple of properties first. We're going to have properties that return the adjacent tiles to this tile. So, like the tile to the left, the tile to the top, bottom, right, and so on. To do this, let's go ahead and have a public tile left, which is the left tile. I'm gonna go ahead and say board instance tiles at the current x minus 1 and at our current y position. But this might return an out of range exception if you, for example, add the 0 coordinate. So we need to check for something. We say if x is more than 0, return this, otherwise return null. So if we are at 0, we cannot return anything to our left because there is nothing to our left. Okay, let's go and copy this and paste it, and we're going to go ahead and add top. So I'm moving clockwise, left, top, right, bottom. The top is going to be the same thing, but the y here, so I'm going to go with y. If y is less than the height of our, is more than 0, I'm going to go ahead and return the tile at our current position on the x-axis, but above us on the y-axis. Because if you remember in our board, when we initialize it, we go from small to big, so the tiles at the lower numbers are above us. Okay, let's go back to the tile, and here we're going to have a public. Let's paste the same code. Right is going to be this time, and I'm going to check if x is more than 0. I'm going to check if x is less than the number of tiles or the width of the board minus 1. So it's going to be like this: x is less than board.instance.width minus 1. We're going to return the tiles at our x plus 1 or null. And finally, for the bottom tile, we're going to go ahead and check if y is less than the height minus 1. We return y plus 1. Okay, and to return all of these at once, we're going to have a property called public tile array neighbors. Okay, it's going to be a read-only property, and it's going to return a new tile array. Here, that's going to take left, top, right, bottom. So it returns the neighbors in order. Okay, each time it's called, so it's not it's not cached. So it won't be called a lot of times anyways, but if you're gonna call it a lot of times, I suppose you should store it in a local variable. So let's go here now and add a function that returns the adjacent or the connected tiles to this tile. Let's go here. It's going to be a recursive function, so you better again focus very well with me here. So we're gonna have a public list of tiles, so tile get connected tiles, and we're going to have a parameter list of type tile, which takes a list of tiles, and let's call it exclude, and it's going to be null by default because it's going to be initialized by this method itself. So let's go ahead and open maybe like Paint. Yeah. Let's create a new document real quick, and let's go with the brush. Yeah. So assuming we have a simple board like this, Okay. Very good drawing skills there. Let's say I want to match all the red tiles. Okay, like this. We have some yellow tiles here. We have some green tiles down here. Let's use the pink as our path drawing tool. Let's zoom in. So, assuming we start here, this tile is going to look at its neighbors, okay, and check if this neighbor, for example, is of the same type. Then it's going to ask this neighbor to return all of its neighbors that are of the same type. So this neighbor is going to go ahead and see, oh, this is not the same color, or less the same type as me. This is not, sorry, this is not, and this is not. So it's just going to return itself. This tile here is going to ask this tile over here, can you please return all of your neighbors that are of the same type? It's going to say, okay, this is not, so it's not going to take this. It'll look here, and it'll find one of its kind. So it'll keep repeating and say, can you please find all your neighbors? This will look down here, say okay, go down here and say okay, this will go down here, then say no, and terminate. So it is going to return this, 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 and this, and this one as well. So let's go ahead and start implementing this. So first we have a var result equals a new list of tiles that contains this tile initially, so it's going to return itself in the list of connected tiles, and let's return this result. Okay, excuse me, and this exclude list over here that we have default to null, we're gonna check if exclude equals to null. I'm gonna say exclude equals a new tile array that contains this tile. Otherwise, we're going to add this tile to it. So you might say, what's the use of this exclusion list? So let's go back to our Paint 3D and let's look here. Let's remove all of these purple drawings. Let's say we moved all the way to this tile over here. So can you please tell me what your neighbors are? So it's going to return this guy over here and this guy over here. But we have already checked for the parent, like this is our starting tile. So if we keep checking for our neighbors, we're going to enter a Stack Overflow or an infinite loop. So this is going to refer to this is going to refer to this, and so on and so forth. Because this neighbors this. Quite a messy explanation there, but the exclusion list makes sure that this tile, for example, never double checks for this tile. So if this tile has already been checked or have been already added to the results list, it'll be ignored. It'll just look for the neighbors that haven't already been added, like this one, and this one will check for this one only, and this one will check for the next one only, and so on. So let's go into InWriter here, and let's do a little loop. So let's go here for each neighbors. So we'll go ahead and say neighbor and the neighbors. We're going to skip the neighbor if neighbor equals to null, or exclude that contains the neighbor. So if the neighbor is excluded, ignore it. Okay, or the neighbor.item is not the same type as my item. I'm going to continue. Okay. Otherwise, the results array is going to, so we're going to add to the results array a range, which is basically going to call neighbor.get connected tiles, and pass in the exclusion list. So as you can see now, let's go over the function again. The result list contains all of the connected tiles to this tile. So let's do like if we have a tile at the beginning of the board at 0, 0, it will return all of the tiles connected to this tile directly or via its neighbors. Okay. The exclusion lists prevents us from entering an infinite loop. Okay. The for each loop over here loops or iterates over all of our neighbors, and it checks if this neighbor is null, ignore it. If it's excluded, ignore it. If it's not of the same, doesn't like have the same item, ignore it. Otherwise, return me all of the tiles connected to our neighbor. Okay. We can see this in action. So if I go in the board here, let's go real quick and add. Let's see a function. Let's go private void update. I'm going to check if input get key down key code dot a, for example. Okay, sorry, it's gonna go return. We're going to highlight or make all of the tiles grow. For example, all the connected tiles to the first tile in the top left corner will be highlighted. Let's go here and say for each tiles at 0, 0 dot connected tiles. I'm gonna say connected tile dot icon dot do dot transform dot do scale to 1.25f, and let's scale it. So it's going to take the play duration. Okay, let's remove the brackets. And this basically says when we click, when you press down the A button, it's going to iterate over all the tiles connected to the one in the top left, and gonna scale them to 1.25 times. Okay, let's go back in Unity. Let's play the game. And unfortunately, we don't have. You know what? We can arrange our tiles. So, just for demonstration, if I press A, you can see it returned all of the tiles connected to this pig over here of the same type. But if I switch this, it won't return anything. Like it won't scale the monkey. Let's move the monkeys and arrange them in a way like this, for example, and press A. It's going to, as you can see, highlight our monkeys. And this is a very performant method. Like it doesn't do that much recursion, and it's bound to end. Okay, so if you have a very large board, you can iterate it over an occur routine, and it won't really take that long. Okay, so that's pretty much it for the getting the connected tiles. Now it's time for popping or matching, as people like to say. Let's remove this update function. And let's go to our canPop method here and add some code. So, how will canPop work? It's going to do a two-dimensional loop. So for y equals less than the height, y plus plus. Let's use var here. Let's say for var x equals 0, x is less than the width, x plus plus. We're going to say if tiles at the current x and y that get connected tiles. Okay, if the connected tiles minus the initial tile, which is basically the tile itself. So I'm going to check. Let's go ahead in our Paint 3D to explain everything. So when this tile starts checking for connected tiles, it builds a list with itself being the first item. So let's assume we wanna match these 3 items, or check if the matches are more than 3, or we have more than 2 matches, more than 2 items connected to us, which means this one and this one, for example, or these 2 over here are connected to this one. So this will be this one here, and this will be that one here. So we skip this first item and we just check for the rest of the connected tiles. So if they are more than 2, more than or equal to, that's a match. Otherwise, it's not. Okay, let's clear this. Let's go into writer again and say, so basically what the skip does, it just skips the specified number of items. So we skip the first one, and then we count them using the extension method .count, okay, and check if it's more than or equal to, then we return true. Oh. Let's remove the braces here as well, and return false by default. So if we can't find any pops, we just return false. Here in the select method, we're gonna await the swapping, and we're gonna say if we can pop after we have swapped the items, then sure, keep the swap. Otherwise, revert the swapping operation. So if can pop, we say I'm gonna call the pop method here. Otherwise, we're going to swap back, await, swap back the selection 0 and selection 1. So as you can see, we're going to swap the tiles back if we can't find any matches, okay? And the pop method itself, okay, excuse me for this, for these delays. So if the pop method, the pop method itself is going to be very simple. It's going to do the same thing as the can pop, but it's just going to do a little bit more, in the sense that it's going to pop the tiles, replace them with new ones, and so on. Okay. So let's go ahead here and say var x. That's right. Yeah. For var x equals 0, var y equals 0. Y is less than the height, y is plus. For var x equals 0, x is less than the width, x plus plus. We're going to store this tile in a local variable, so var tile equals tiles, at the current x and y. And let's go ahead and see. We can say var matches or connections equals, let's name it connected tiles. Say tile.get connected tiles. We are going to go ahead and say if connected tiles dot count is less than 2. So if there is if like the connected tiles to this one is less than 2, we ignore it. There is no popping to do here, okay? So let's go ahead and say continue. Otherwise, we're going to pop the tiles. How? Okay, we're going to go ahead and have a var sequence is going to equal to, let's call it deflate sequence, which basically we're just going to scale the icons down. So it shows that it has popped, okay? Deflate sequence equals tween sequence, and we're going to iterate. So for each connected tiles, we're going to go and call connected tile. Let's remove this here, and we're going to say deflate sequence dot join connected tile dot icon transform the to scale to vector 3.0, so it's scale all the way down, and take the tween duration. Okay, that's the first thing. Then we go ahead here, okay, say await deflate sequence. Yeah, sorry, we need to make this method asynchronous. So here I say deflate sequence dot play dot async await for completion, or async wait for completion. Okay, Once the deflation sequence is complete, we're going to iterate over the connected tiles and randomize their item. Okay, so we're going to go ahead here. We're going to say for each again, connected tiles, connected tile, I'm going to say connected tile dot item equals item database dot items random at range 0 item database items dot length, just like we did above. And while we're inside this loop, we need to add the inflation sequence. So we're going to go ahead and say await inflate sequence equals tween sequence var inflate sequence equals tween dot sequence. We're going to go ahead and add or join a tween to the inflation sequence. So we say connected tile dot icon dot transform to scale all the way back up to vector 3.1. It's going to take tween duration. Then we go ahead here and say await what's it called? Yeah, inflate sequence. Dot play dot async await for completion. This should, in theory, allow us to pop as many tiles as we can, as long as there are pops on our board. Okay. Excuse me. Let's go inside Unity Editor. Everything has compiled. Okay. Let's play the game. Let's see. So let's move this here. It pops this and this and this, which is perfect. It keeps popping. But there is a big little problem here that it even wait. It pops them even if they have like 2 items only in a what's it called in a connection. Okay, let's go here, and as you can see also, before we go ahead, if there's no matches, they swap positions back. Okay, let's close the play mode. Let's go in Rider. If connected tiles is less than 2, skip them. Okay. Oh, sorry. Connected tiles dot skip 1 dot count. So if I go here, Unity again, wait for the scripts to recompile. Let's run the game again. And let's move the piggies over here. Matches these, all are 3 matches. Okay, perfect. But what if I have only 2? Oh, this is not 2. Yeah, it doesn't match them if I have only 2. So as you can see, I have 3 items, 3 items as well. Okay, perfect. So as you can see, it's working pretty fine. And if we have 4 items, okay, let's try and match these, match those as well, match those as well. So yeah, that's pretty much it for the matching and popping of the tiles. Now we need to add some sound effects and the scoring. So scoring is going to be pretty simple. Let's go here in the canvas and add a UI element, text element. Let's call it score text. Let's disable the debug inspector. Let's go align the text to, or anchor the text to the top left corner. 0, 1. As you can see, we align it to the top left here. Let's set it to auto size, align it to the middle center. Say score equals 0. I might want to change the color, but I'm going to just keep it white. Okay. Let's go in Rider. And let's add let's go ahead and add a new script. Call it score counter. Or you know what? Let's rename it to just score. score counter, which is a little confusing, but I'm just going to use it. So sealed class, I'm going to remove this, these namespaces. You're going to have a public static, private static integer called score, and a public static int. You know what, we might want to use the singleton pattern here, so let's go ahead. Public static score counter instance, let's say get private set, just like we did in the board class. Gonna have a private void awake, let's say instance equals this. I'm gonna use the expression body. We're going to have a public integer and call it score, a private integer and call it first underscore score. Then we have a public int score, which is the property. I'm going to say get score and set if the score is not already equal to the value. If it's already equal to the value, return. Otherwise, set the score to the value. We need to reference our score text. Let's add a serialized field, private TMP text mesh pro UGI text. Say score text, and we can go ahead and say score text. Let's set text. Use an interpolated string. Say score equals score. That's pretty much it here. Let's go back to our port.cs and do one simple thing in the end over here. Or you know what? Once the deflation sequence is done, we're going to increase the score. So we go here and say score counter.instance.score plus equal tile.value, .item.value times the connected tiles.count. So it's going to give a score depending on how many tiles just popped, and multiply this number of tiles that have just been popped by the value of the item. Okay, let's go on Unity. Everything has compiled, perfect. Let's go to score text, disable these, add the score counter component, and let's go and play the game. Let's see. As you can see, we get score. But you might have noticed that there were some pics down here that weren't popped when we were doing the popping and stuff like this. So this is because we go from the top left to the bottom, and when we change the items on each tile, some items might pop up in a new position that can be popped, but since they have already passed in they were like before our current indices, they have skipped. We're going to need to reset the loop to go from the top left again all the way to the bottom right. To do this, simply go to writer, and underneath the inflation sequence we reset, so we say x equals 0 and y equals 0. This is going to happen only if there are matches here. So this ensures that if there are pops, they will be if there are matches, they will be matched and popped. Okay. Now let's add some sound effects. So let's go here in our board and add a couple of fields. First, a serialized field, private audio clip, collect or pop. So I'm gonna just call it collect sound, and we have a serialized field here as well. We call it it's of type audio source, so we can call it audio source, no underscores. Okay, and go all the way down here, and before the deflation sequence begins, I think we should give the score. Okay, and play the sound effect. So we're going to say audio source dot play one shot collect sound. Let's go in Unity. As the completion is done, let's go to the board and add in audio source component. Let's go inside of it, change the 3D sound settings, make sure it's 2D, disable play on awake. Let's assign it. Let's drag our collect sound and let's play the game. So, as you can see, there are some matches here that are initially not solved. To do this, we might go ahead here and add, in the start method, we might add pop over here, but I don't really prefer this. You can go ahead and do some shuffling algorithms. It's pretty simple. You can shuffle the board until there are no pops possible. But for the sake of the tutorial, we're going to keep it simple and not do this, okay? I'm just going to go in Unity now and test the game. As you can see, we play sound effects and we get scored. And as long as there are pops available, we do pop them. Okay. So I think I should add that this part over here has been added to the video after it has been initially recorded. I missed that I forgot to add or to prevent swapping tiles from anywhere on the board. So I'm gonna show you what I mean right now and how to fix it. So currently you can swap tiles like this. So this can go here, which is not really what we want. We want only adjacent tiles or neighboring tiles to be swappable. Okay, let's close or exit the play mode. Let's go in Rider. Let's go all the way down to pop method. Sorry, all the way up to the select method, and check if selection that contains tile. No, we're not going to do this. We're going to check if the selection is more than 0. So if you have already selected a tile, okay, I'm going to remove this, and we're going to we need to check if we don't already have this tile. I'm going to check if the selection is more than 0. Okay, I'm going to add some code here, so let's add a comment there for now. And we're going to say if we have already selected something, do the following here. Otherwise, just add this tile to the selection. So, if the selection is more than 0, so if you have selected a tile, we're going to check if the other incoming tile is contained within the first tile's neighbors. So to do this, we check if array dot index of, which basically returns the index of a specific value inside an array. So array.index of selection, okay, sorry, tile selection 0.neighbors, and the incoming tile is not equal to -1. To say selection.add a tile. So what this does over here is check if the tile, the second tile that we're going to add to the selection, is one of the first tile's neighbors. Otherwise, it'll just not do anything. So let's move this up like this and make it a single line. And let's go back to Unity. Okay. Let's play the interplay mode. Let's go and try moving two things far away, it won't work, but we can swap neighbors. So as you can see, this has been an oversight, and I have just added this part to the video, so please excuse any confusion that this might have caused. Okay, so I think that's pretty much it for the game. I hope you enjoyed this tutorial. If you did, please leave a like and consider subscribing. Check out my assets on the asset store and my games on itch.io and my assets as well on itch.io. Thank you so much for watching. I know this was a long tutorial, but hopefully it was useful. Thank you for watching again, and I'll see you in the next one.